class. Today we're taking a look at exponential models. Now remember, over the course of the year we've taken a look at finding linear models and quadratic models. Well, today we're going to take a look at finding exponential models. So that is, we're going to find a line of best fit, actually a curve of best fit, that models a data set that seems to have constant growth or constant decay. So let's just jump into a few examples. It says the amount of sunlight that reaches the plant life underwater determines the amount of photosynthesis that takes place. That's a tough word. The table and the graph below give the percentage of sunlight that is present at various depths in parts of an ocean. Now, the percentage of sunlight is known to depend exponentially on the graph, on the depth. So find an exponential equation to model the data using the 2 points, 0, 100 and 50, 0.001. All right, well, we're going to first start off by finding this exponential model by hand. Remember, our exponential equation takes on the form y equals a times b to the x. Now, a is our initial amount. That's actually when our x value takes on 0. And you can see that that's our first point here. So our initial amount is actually 100. So we already know y equals 100 times b to the x. Now remember, b is our growth factor, or in this case our decay factor, because the amount or percentage of sunlight is decaying as the depth increases. So we need to find that, and the best way to do that is to take our second point here. We have an x value and a y value, and let's substitute those in. So we have 0.001 is equal to 100 times b to the 50th power. Now we're going to isolate b and then solve for it. Divide both sides by 100, and we will end up with b to the 50th power is equal to 0.00. Let's see, there's 1, 2, 3, 4, 5 zeros and a 1. 1, 2, 3, 4, oh, just kidding, there's 4 zeros and a 1. So let's try that again. That should be 0.00001. Alright, now to find our growth factor, we got to get b by itself. So to undo the 50th power, we need to take the 50th root, or raise that to the 1 over 50th power. And what we do to one side, we have to do to the other side. Now we can check this on our calculators, but when we do this, we'll take 0.00001 to the 1/50th power, and that's going to give us 0.794. So our growth factor here is 0.794. So that leaves us with the equation y equals 100 times our growth factor, which is 0.794, and it's less than 1, so that's indicating that's decaying to the x power. Alright, in part B of this it says to do the same thing but use another point such as 20, 1.5. So our initial value here is still going to remain 100, and we're going to substitute the new points, x is 20 and y is 1.5, into our equation. I should say 1.15. Alright, so here's what we get. B to the 20th now. We'll divide both sides by 100 again. That means we'll move our decimal place over 2 places to the left, so that gives us 0.00115 is equal to b to the 20th. Now to undo our 20th power, let me just check my math here. I again have too many zeros in there, so we got to change that. It should be 0.0115. And now we got to raise that to the 1/20th power. So we're going to do the same thing to the other side. 1/20th power, and this is going to give us a growth rate or decay rate of 0.799. So it's slightly different than the one we calculated at first. But our equation here becomes y equals 100 times our growth factor of 0.799 to the x power. Now you're going to do the same thing. Try that with the 0.30, 0.12. Follow the same steps that we just did right there, and let us know the equation you get tomorrow in class. All right, let's move on now, and now we're going to pull out our graphing calculators to show you that you can actually do the same thing on our graphing calculators. So remember our stats menu. We're going to select stats and then over to edit, and we'll edit our lists here. So our x values will be list 1, our y values will be list 2. Okay, once we have our list 1 and list 2 entered into our lists, we're going to go back to the stat function and now over to calc, and we're going to arrow down till we see the exponential regression. So here it is, it's my number 10 option. EXPREG is exponential regression. We'll press enter on that, and we'll select list 1 and list 2, or keep pressing enter until you see calculate highlighted. And once you press enter again, you'll get your exponential regression equation. So you see here that y equals a times b to the x is the form that they give it in. And a, their initial value is 107.9, and their growth factor is 0.794 if you round to the nearest thousandths. So you can see here we weren't too far off. Our graphing calculator gives us just a slightly different equation. But that equation again should be y equals 107 point, what was it, 9? Yep, times 0.794 to the x power. Okay, let's take a look at another example here. Example 2 says the amount of decaying substance that remains after d days is shown in the table below. Fit an exponential model to the data. Determine if the exponential model is appropriate. So let's take a second here, and our days are our x-axis, our amount in grams here is going to be our y-axis, and let's take a second to plot this data. Okay, you can see our data is plotted somewhat accurately here, and if we were to fit a curve to that data as best we possibly can, you can see it kind of tapers off there towards the end, as if it's reaching kind of that lower limit. So you see here, it looks like there is some constant change. So we could also take a look at just finding a constant ratio between terms, and you'll remember how to do that. You just take that second term, divide it by the first term. So if I take 650 and divide that by 800, it gives me approximately a 0.8125. Now if I pick another set of terms here, like the third and the second term, if I take 512 and divide it by 650, again I get somewhere pretty close to that. It comes out to be about 0.80 something there. So right around that 0.8 looks like to be our constant ratio. Now it says to use the model to estimate the amount of days, the amount of substance remaining after 20 days. So we actually got to come up with our model now, and we'll go back to our graphing calculator and we'll enter our data in here for list 1. Okay, now that we have our data entered, we're going to go back to stat, over to calc, and then down to exponential regression again, and press enter on our exponential regression to calculate that exponential regression curve. When we do so, we get a value, our initial value of 998.2, and our growth factor of 0.801. So that model looks like this. We'll have y is equal to 998.2 times our growth factor of 0.801 to the x power. So there's our model. Now it says to use our graph or our table to find out how much substance is remaining after 20 days. So heading back to our calculator, we'll just use this equation here, and we'll substitute 20 in for that power. So the amount of substance that remains looks to be about 11.8 grams. So we can write that in here. Our function here after 20 days should be equal to about 11 point, what do we say, 8 grams.